let's finish up our chapter 19 notes. So here we're looking at a drip rate of 30 drops per minute. And we're looking at 6 hours. So I want to convert my minutes to hours, so I'm going to throw in my conversion factor right here. And we have a 10 drops per ml. I'm going to put my drops in the denominator, because my question is how many mLs will infuse. So mLs have to be in the numerator, and I need the drops in the denominator to cancel. So I think I have it set up. Let's see. Drops, drops, hours, hours, minutes, minutes, and I'm left with my mLs in the numerator, which is exactly where it needs to be. So that's my setup. And now I just multiply and divide. I'm going to cancel out this 0 with with that 0. So now I just take 6 times 6, 36 times 30. (1,080 mLs). How many mLs will infuse in 10 hours? So I have 13 drops per minute. I'm going to throw my conversion factor in again, 60 minutes in 1 hour. We have 10 hours. And again, my drop factor, 15 drops in the denominator. So it's set up exactly as I set up the last one. Drops, drops, minutes, minutes, hours, hours. My answer will be in mLs. And when I do the 13 times 60 times 10 divided by 15, I get 520 ml. Example 14, an IV of 1,000 mLs, D5 1/2 normal saline. Again, we don't care about that part. We're looking at 25 drops per minute. (60 minutes in an hour). 4.5 hours from 2200 on Tuesday to 2:30 in the morning on Wednesday is 4.5 hours, and our drop factor is 20 drops per ml. So you see the setup is the exact same way for all 3 problems. It just becomes consistent and routine if you always do it in the same fashion. Drops, drops, hours, hours, minutes, minutes, and we should get 337.5 ml. Now this one in question 15, it's asking a little bit different. So the way I did it was first I figured out my rate, and then I used my rate as a ratio. Not the only way to do it, but I started out with 20 drops per minute, 60 minutes in an hour, and then 15 drops per ml. So we have 80 mLs per hour. So then I set up 80 mLs per hour as a ratio to find out at that rate how long would it take us for 300 mLs. So I do my cross products. 80x equals 300, divide both sides by 80, so how many hours will it take? 3.75 hours. I like my answers in hours and minutes, so I would have 3 hours. 0.75 of an hour, I would multiply that by 60 to get 45 minutes. So here we're starting out at 38 drops per minute, 60 minutes in an hour, 10 drops per ml, 228 mLs per hour. Now I'm going to set up my ratio down here. 228 mLs per hour using that rate. We want to know 1,000 mLs. 1,000 mLs. How long will it take us? 228 x, 228 times x equals 1,000 times 1, divide both sides by 228, and we get x to equal 4.386. I want to know, what does this mean? So we know this means 4 hours. So my 0.386 times 60 will give me 23 minutes. So it'll take 4 hours and 23 minutes. Okay, so here we started with 775 milliliters, and then 3 hours later we had 500. The patient had received 500, so we have 275 left. I got that by taking the 775 minus the 500. So we have 275 mLs left 3 hours later, so we would have 3 hours to go. My conversion factor is 1 hour has 60 minutes. Hour is going to go in the numerator, so they cancel out. My drop factor is 10 drops per ml. And when I do the math, I get 15.27, and we're going to make that 15 drops per minute. ml, ml, hour, hour, drops per minute. Kind of cut the one off there. There we go. Flow rate in drops per minute. So we have volume over time. The volume is 1,000 over 8 hours. They want it in drops per minute. 1 hour is 60 minutes. And we have a drop factor of 10 drops per ml. So I have drops per minute, and when I multiply across and divide across, looks like I get 20.83, and I'm going to round that up to 21 drops per minute. After 5 hours, 700 ml remain, so I have 700 remaining. And we have 3 hours left. My conversion factor, 1 hour, 60 minutes, 10 drops per ml. ml, ml, hour, hour. My answer is drops per minute. Perfect. So when I multiply 700 times 10 divided by 3 times 60, I get 38.89. I'm going to round that up to 39 drops per minute. Now we're going to use the formula change over original. So our original is our 21. Our change, 39 minus 21, is 18. 18 divided by 21 gives me a decimal of 0.86, which is 86%. And is it within the guidelines? No, it is not. Example 19, we have 300 ml over 1, that's out, times 40 ml in over 100 ml out. and that equals 120 ml. That is our replacement volume. So now here, in excess of 100 mLs, so we subtract 100 from the 320, and we have 220 mLs over 1 times 1 ml over 2 mLs. And again, that would be out, in, out, and that would equal 110 mLs. And that is chapter 19. Again, if you have any questions, please post it in the document sharing.